Getting bonding bushings securely requires attention to detail. Firstly, ensure the connector is clean and free of debris. Contaminants can impede proper threading and secure contact. Secondly, consider slightly lubricating the threads of the connector. A dry lubricant or dielectric grease can facilitate smoother rotation of the bonding bushing. Be conservative with the lubricant. Excessive amounts can attract dirt and compromise the connection over time. Carefully thread the bonding bushing onto the connector, making sure it spins freely. Resistance indicates potential thread damage or debris obstruction. Investigate and rectify any issues before proceeding. Tighten the lock nut firmly, then back it off slightly. This seemingly counterintuitive step ensures that the lock nut isn't excessively tight, which could restrict the bonding bushing's ability to spin and align properly. Hold the connector steady with one hand and spin the bonding bushing onto the connector with the other hand. Maintaining a firm grip on the connector is crucial for controlled and effective threading. Apply firm pressure while spinning until the set screw holes align with the threads on the connector. This pressure helps overcome any remaining friction and encourages proper seating of the bushing. Insert the set screws and tighten them securely. These screws provide the final mechanical lock, ensuring a reliable electrical connection. When it comes to getting the screws facing outward, this can be challenging. Firstly, when tightening the lock nut, rotate it slightly while tightening to prevent the bonding bushing from twisting. This subtle movement can sometimes nudge the bushing into a favorable orientation. Secondly, use a visual aid, such as a mirror or camera, to inspect the screw orientation before tightening the lock nut fully. This proactive approach allows for adjustments before the connection is fully secured. If the screws are facing inward, loosen the lock nut slightly and rotate the bonding bushing until the screws are in the desired position. Retighten the lock nut securely. This may require a few iterations to achieve the desired outcome. Regarding recommended brands, firstly, Penelec is a reputable manufacturer. Secondly, RTE-Corcom is another reliable option. Thirdly, Hubble Power Systems is known for quality electrical components. Additional tips to consider include firstly, using a torque wrench to tighten the lock nut and set screws to the specified torque values. Over-tightening can damage the connector or bushing, while under-tightening can compromise the connection's integrity. Consult the manufacturer's specifications for the correct torque values. Secondly, inspect the bonding bushings regularly for any signs of damage or loosening. Periodic inspections can identify potential problems before they escalate into safety hazards. Thirdly, if problems continue, contact the manufacturer for technical support. Manufacturers often have specialized knowledge and can offer tailored solutions to specific installation challenges. The National Electrical Code (NEC) provides guidelines for proper grounding and bonding practices. Refer to the relevant sections of the NEC, such as 250.92 and 250.96 for detailed requirements. For example, NEC section 250.92 covers bonding of equipment containing over 250 volts to ground. NEC section 250.96 discusses bonding other enclosures. Regarding the supplied location, Windsor, Colorado, ensure all installations comply with local amendments to the NEC and any other applicable local codes or regulations. Always to energize circuits before working on electrical systems to prevent electrical shock. Verify the absence of voltage with a reliable voltage tester before commencing any work. Wear appropriate personal protective equipment, PPE, such as safety glasses and insulated gloves, to minimize the risk of injury. Ensure adequate lighting in the work area to improve visibility and reduce the likelihood of errors. When working with multiple conductors, label each conductor clearly to avoid confusion and ensure proper connections. Use appropriately sized tools for the task at hand. Avoid using tools that are too small or too large, as this can lead to damage or injury. Dispose of any waste materials properly in accordance with local environmental regulations. Maintain a clean and organized work area to minimize the risk of accidents and improve efficiency. When tightening connections, use a consistent tightening pattern to ensure even pressure distribution. If you encounter any unexpected situations or difficulties, stop work and consult with a qualified electrician. Document all work performed, including the date, time, and specific tasks completed. This documentation can be helpful for future maintenance and troubleshooting. Periodically review your electrical knowledge and skills to stay up to date with the latest industry standards and best practices. Attend training courses or workshops to enhance your understanding of electrical systems and improve your work quality. By following these guidelines and best practices, you can ensure the safe and reliable installation of bonding bushings and other electrical components. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. For example, when installing a bonding bushing on a metallic conduit, the lock nut should be tightened to provide a secure mechanical connection and a low impedance ground fault path. The bonding bushing set screws should then be tightened to further enhance the connection and prevent loosening due to vibration or thermal expansion. The size of the bonding conductor should be selected in accordance with NEC Table 250.102 Coron, based on the size of the ungrounded conductors. The bonding conductor should be installed in a neat and workmanlike manner and should be protected from physical damage. When installing bonding bushings on enclosures containing sensitive electronic equipment, consider using low-noise bonding bushings to minimize electromagnetic interference. These bushings are designed to provide a low-impedance ground path while reducing the generation of electrical noise. When working in corrosive environments, use bonding bushings made of corrosion-resistant materials, such as stainless steel or epoxy-coated steel. These materials will help to prevent corrosion and ensure a long-lasting connection. Before installing any bonding bushings, carefully inspect them for any signs of damage, such as cracks, dents, or corrosion. Damaged bushings should be replaced immediately to ensure a safe and reliable connection. When tightening the set screws on bonding bushings, avoid over-tightening them, as this can damage the threads on the connector. Use a torque wrench to ensure that the set screws are tightened to the manufacturer's specified torque value. After installing bonding bushings, test the continuity of the ground path with a multimeter to verify that a low impedance connection exists. This test will help to identify any potential problems with the installation. Periodically re-inspect the bonding bushings to ensure that they are still securely fastened and that there are no signs of corrosion or damage. Regular maintenance will help to ensure the long-term reliability of the grounding system. The goal of bonding is to create a low impedance path for fault current to return to the source. The impedance of the bonding path is crucial for the proper operation of overcurrent protective devices, such as circuit breakers and fuses. A high impedance bonding path can prevent these devices from tripping quickly enough, which can lead to equipment damage or electrical shock. The NEC requires that all metallic enclosures and equipment that are likely to become energized be bonded together to form a continuous electrical path. This includes items such as conduit, junction boxes, motor frames, and equipment grounding conductors. The size of the bonding conductors must be sufficient to carry the available fault current. NEC Table 250.102 current provides guidance on the proper sizing of bonding conductors based on the size of the ungrounded conductors. Bonding can be accomplished using a variety of methods, including bonding jumpers, bonding bushings, and grounding electrodes. The choice of method will depend on the specific application and the requirements of the NEC. Bonding jumpers are used to connect two or more metallic enclosures or equipment together. They are typically made of copper or aluminum and are sized according to NEC Table 250.102 Coron. Bonding bushings are used to bond conduit to enclosures. They provide a secure mechanical connection and a low impedance electrical path. Grounding electrodes are used to connect the grounding system to the earth. They are typically made of copper or steel and are buried in the ground. The selection and installation of grounding electrodes must comply with the requirements of NEC sections 250.50 through 250.70. In addition to the NEC, other standards and codes may also apply to bonding and grounding systems. These include standards from organizations such as IEEE, ANSI, and all. It is important to be familiar with all applicable standards and codes before designing or installing a bonding and grounding system. Proper bonding and grounding are essential for electrical safety. They help to protect people and equipment from electrical shock and fire hazards. Always follow the requirements of the NEC and other applicable standards and codes when working on electrical systems. If you are not qualified to perform electrical work, consult with a licensed electrician. It is better to be safe than sorry when it comes to electricity. Bonding ensures electrical continuity and a low impedance path back to the source, which helps overcurrent protection devices operate properly in the event of a fault. The selection of appropriate bonding methods depends on factors like the type of equipment being bonded, the available fault current, and applicable codes. For example, when bonding metal water piping, a bonding jumper should be sized according to NEC Table 250.102 cone and connected to a suitable grounding electrode conductor. When bonding a service disconnect enclosure, a bonding bushing should be used to ensure a solid connection between the conduit and the enclosure. In agricultural buildings, special attention must be paid to bonding and grounding due to the presence of livestock and wet environments. The NEC provides specific requirements for bonding and grounding in agricultural buildings in Article 547. Surge protective devices, SPDs, also rely on proper bonding to effectively divert surge current to ground. The bonding impedance between the SPD and the grounding electrode system should be kept as low as possible to minimize voltage rise during a surge event. Regular inspections of bonding connections are essential to ensure their integrity. Look for signs of corrosion, loose connections, or physical damage. Any deficiency should be corrected promptly to maintain the effectiveness of the bonding system. When adding new equipment to an existing electrical system, be sure to properly bond the new equipment to the existing grounding system. This will help to ensure that the new equipment is protected from electrical faults and surges. In healthcare facilities, the bonding and grounding system is critical for patient safety. The NEC provides specific requirements for bonding and grounding in healthcare facilities in Article 517. Isolated grounding systems are sometimes used in healthcare facilities to minimize electrical noise and interference. However, isolated grounding systems must be carefully designed and installed to ensure that they do not compromise patient safety. The use of exothermic welding, also known as CAD welding, is a common method for creating permanent bonding connections. Exothermic welding creates a molecular bond between the conductors, resulting in a very low impedance connection. In hazardous locations, such as areas where flammable gases or vapors are present, special bonding and grounding requirements apply. These requirements are intended to prevent the accumulation of static electricity, which could ignite the flammable atmosphere. The NEC provides specific requirements for bonding and grounding in hazardous locations in Articles 500 through 516. When working on electrical systems in hazardous locations, it is essential to follow all applicable safety procedures and to use approved equipment. Static electricity can be generated by the movement of fluids or gases through pipes or hoses. Proper bonding and grounding can help to prevent the accumulation of static electricity and reduce the risk of ignition. The resistance of the grounding electrode system should be measured periodically to ensure that it is within acceptable limits. A ground resistance tester is used to measure the resistance of the grounding electrode system. The NEC requires that the resistance of the grounding electrode system not exceed 25 ohms. If the resistance exceeds 25 ohms, additional grounding electrodes must be installed. In areas with high soil resistivity, it may be necessary to use special grounding techniques such as chemical grounding rods or ground enhancement materials. These techniques can help to reduce the resistance of the grounding electrode system. The color green is used to identify grounding conductors. This helps to prevent accidental misconnection of grounding conductors to other circuits. Grounding conductors must be insulated, unless they are installed in rigid metal conduit or intermediate metal conduit. The insulation helps to protect the grounding conductor from corrosion and physical damage. Grounding conductors must be sized according to NEC Table 250.122, based on the size of the overcurrent protective device protecting the circuit. The grounding conductor must be large enough to safely carry the available fault current. Grounding electrodes must be protected from physical damage. This can be accomplished by installing the grounding electrodes in a protective enclosure or by burying them deep enough in the ground. Grounding electrodes must be located where they are accessible for inspection and testing. This allows for periodic verification of the grounding system's integrity. The use of ground fault circuit interrupters, GFCIs, is an important safety measure that can help to protect people from electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. GFCIs work by monitoring the current flowing in the hot and neutral conductors of a circuit. If the current difference exceeds a certain threshold, the GFCI will trip and energize the circuit. This can help to prevent electrical shock if someone comes into contact with a live wire. Arc fault circuit interrupters RTEs are another important safety measure that can help to prevent electrical fires. RTEs work by monitoring the current flowing in a circuit for the characteristics of an arc fault. If an arc fault is detected, the RTE will trip and energize the circuit. This can help to prevent electrical fires caused by damaged or worn wiring. Bonding and grounding are complex topics that require a thorough understanding of the NEC and other applicable standards and codes. If you have any questions or concerns about bonding and grounding, consult with a licensed electrician.